Hello, today we're going to be doing one of my favorite topics, which is multiplying and dividing rational expressions. So remember, a rational expression is basically a fraction, can be written as a numerator over a denominator, and what we're going to be doing is multiplying two of these things together and then simplifying as we go. Usually they simplify very nice, and there's a lot of canceling, which is one of the reasons why I love them. Okay, the first thing we're going to do is create one fraction by putting the numerators and denominators together. So it's 8, and it's going to be 8 times. So the 24 minus 2v minus v squared. And then on the bottom, we are going to have the 4v plus 24, and then that is going to be next to the v minus 4. What we're going to do next is you are going to want to factor everything you can. Okay, so to factor from here, I notice on the top that is a quadratic, so you can do the X method or whatever way works for you to factor that. For the numerator, you should get an 8, and I'm actually going to factor out the negative sign and then do a little bit of rearranging. So instead of a minus v squared at the end, it's going to be a positive v squared, and then it's going to be a positive 2v, because again, we're factoring out the negative, and then that positive 24 will now be a negative 24. On the bottom for factoring out, I just noticed in the first term, I have a 4 that can come out, and I'm left with a v plus 6. And then the last one, v minus 4, that's just going to stay a v minus 4. I still have a little bit of factoring that I can do. So on the top, I have that negative 8. And then if I'm going to factor that quadratic, it would end up being a v plus 6 and a v minus 4. And then on bottom, we still have that 4v plus 6, v minus 4. And hopefully you see that some of these numbers are pretty familiar. Now, here's what I think is the best part, and that is simplifying, and that means everything that is going to be canceled out. So just right off the bat, anything you have on top and bottom reduces to 1. So I'm going to cancel out that v minus 4 on top and bottom, the v plus 6 on top and bottom, and then 8 over 4. Those have 4 in common. 4 goes into 4 once. 4 goes into 8 twice. And when we do that, our final answer ends up being a negative 2 over 1, which is also just known as a negative 2. Now, here we also have to state the excluded values. So what it means to state the excluded values is basically anything that we crossed off or anywhere the denominator would equal 0. Where we are right now, we're just at a negative 2. The denominator is 1. 1's never going to equal 0 because 1 equals 1. But I did cross out a v plus 6 and a v minus 4. So I'm going to need to know, well, where does v plus 6 equal 0 and where does v minus 4 equal 0? Hopefully you see that when v equals a negative 6 or a positive 4, right? That is when either of those will go to 0. And because they were canceled out of the numerator and the denominator, that means they are wholes. So there are wholes in the graph where v equals negative 6 and where v equals 4. And then our rational expression just simplified all the way down to a negative 2. Okay, we're going to do a division one next, and it's almost exactly the same. You just have to remember when you're dividing fractions, you flip the second fraction, so you take the reciprocal of the second. All right, so like I said, we're going to do a division one right now, and the steps are exactly the same, except for at the beginning, we have to take the reciprocal of the second fraction, and then we will be doing multiplying, and again, looking for excluded values at the end. So for this, I'm going to have well, hold on, 6m, maybe 6m over m plus 3, and it's going to be multiplied by the reciprocal, so m squared plus m minus 6 over m minus 2. Just like before, we are going to turn this into one fraction. So I'm going to have a 6m on top, and then the m squared plus m minus 6. On the bottom, those two things next to each other, m plus 3 and m minus 2, because remember when we multiply, they go next to each other. Next step was to factor. So I'm going to have to factor anything I can. If I look at the denominator, that's already factored. There's nothing else I can pull out. There's no GCF, and there are already, two binomials. On the top, the 6m is just going to stay a 6m. And then m squared plus m minus 6. Again, you can factor that any way you want. And when you do, you should get an m plus 3 and an m minus 2. Because remember, 3 plus negative 2 is at positive 1, which is the middle coefficient. And then 3 times negative 2 is negative 6. The next step, we are going to do any canceling that we see. So I notice m plus 3 and m plus 3 cancels, m minus 2 and m minus 2 cancels, and the only thing I'm left with is a 6m. Now, be careful for this, you guys. The 6m, it's over 1, because remember when we're canceling, same number on the top and bottom, it reduces to a 1. So it's not 6m over 0, so just be careful. And like we said, that is just 6m. For the excluded values, the denominator in this one, again, is just 1. If that denominator had a variable in it, we'd have to find out where it equals 0. Then that would be an asymptote. But in this case, it's just 1, so it will never equal 0. So we just need to look now at the things we canceled. So we know that we are going to have a whole because we canceled, and we have to figure out where. So we need to know where m plus 3 equals 0, and we need to know where m minus 2 equals 0. Hopefully at this point you can do this in your head, that it's going to be at negative 3 and at 2. So there's a whole at m equals negative 3 and at m equals 2. And that would be the final answer. So we have divided the two rational expressions, then we have found any excluded values, and we have said if it's an asymptote or if it's a whole.